I mentioned in the last video that we could have some variations on the Fibonacci sequence and thus be able to change the recursive formula. Problem 22 is one of those. Now, I have not written the entire problem here, so if you haven't read that problem, you should stop the video now, take a look at your text at problem number 22 and read that. Basically, the difference between this problem and the original Fibonacci sequence is it says that each time, instead of begetting a single male and a single female, getting one new pair, they always produce 4 new males and 4 new females, which means we get 4 pairs. Part A of this problem, and there are 3 parts, is asking us to figure out the recursive formula. And I've done that here already. It does tell us that we're going to use R sub 0, just going back a second, R sub n is the number of pairs, and it's important to notice that that's pairs of rabbits active in a particular month n. In part A, it's saying we should make R sub 0 1, and then come up with a recursive formula for this. Well, in the first month, we're going to start with just 1 pair. So R sub n is going to equal to, well, using the second rule of this Fibonacci sequence dealing with rabbits, which says no rabbits die, we're going to have all of the rabbits who've ever been there here still. So we're going to have all the rabbits from the previous solution. But then we're going to multiply 4 because it's going to make 4 pairs times however many we had 2 ago. So this is our recursive formula which we're going to use. The second part of the problem is asking us to use that recursive formula to figure out these values down through 6. Well, we know R sub 0, R sub 1 are both going to be 1. And R sub 2 would then be found by taking R sub 1 and adding 4 times R sub 0. So what this is it's 1 plus 4 times 1, or we now have 5 in the second month. Now looking at this pattern, R sub 3 is going to be R sub 2 plus 4 times R sub 1. So what this is going to be is the 5 that we had before plus 4 times however many we had back here, which is 1. Well, 5 plus 4 makes this month, the third month, have 9 pairs. Well, you can see the pattern for this is always going to look the same. We could kind of get all of the first terms here, just changing the subscript going down. We have the same coefficient of 4, change the subscript going down here. So using the actual numbers, this one's going to be 9 plus 4 times 2 ago, which is 5. We do that, we get 29. The next one's going to be those 29 plus 4 times 9 is equal to 65. The next one is going to be 65 plus 4 times the 29, which is what we had 2 ago, which makes it 181. And so those are the values for R sub 6. Part C asks us to figure out what this would be after 12 months. Yuck. First of all, I'm not going to do that to you on any kind of a test question. But let's take a look at what happens here, because there is something important about how that last question is being asked. So let's go on with this. Let me work ahead just a little. Okay, I continued on with this to go through R sub 12. And I promise you, I'm not going to do that to you on a test, because once you get down to here, you know, it's really just checking whether you can work a calculator or not. But there's an important point here at the end. You do notice how quickly this goes up after a little while. But the other important point is, the question in C was, how many rabbits do you have at the end of the year? It's asking how many rabbits. People are almost always tempted to say 49,649. But remember, at the beginning of this problem, we said that was the number of rabbit pairs. So it's almost like a trick question, but it's a classic question to ask with these things. Because what you have to do then is to take that final number, multiply it by 2 to get that you actually have over 99,000 rabbits at the end of the year, which kind of matches what I think I see is going on in my yard.